Welcome back, guys. I'm going to today discuss about the null points concept. In all three fields, I'll discuss. First of all, in case of gravity, that means gravitational field. So in gravitational field, the source of gravitational field is mass, we know. The source of electric field is charge, we know. And source of magnetic field is magnet. And electric current also, current element. So that already in one of the video before video I have given. So in gravity, means these are the masses, so that it cannot be negative. So gravitational force or field between the M1 and M2 become zero at one point between M1 and M2. So it is always between M1 and M2 only. Never the field is outside the M1 and M2. Never and nearer small mass. The field is nearer to small mass. So whereas center of mass means it is heavier mass. M1 R1 equal to M2 R2. The center of mass is lies near the heavier mass. But field zero, null point lies near the smaller mass. So remember that. So now calculation of null point in this case. So this is very important formula. So see, this is this one. The null point distance from first mass, that equal to x equal to d by 1 plus m2 by m1. This is from first mass because denominator m1 is there. If null point you take from second mass, see here I have taken m1 from x. This is the null point. Null point is lies from m1 in the x distance. Therefore m1 by x square I have taken field here. Here gravitational field is attractive nature. So in the force direction, attractive force direction. These two are opposite and equal in magnitude. So the net force is equal to 0. E1 minus E2 is equal to 0. E1 equal to E2. So here it is got answer. For example, if you take from x2, from m2 if you take, in the x distance, null point is x, m2 by x will come here. Here I have taken from m1, therefore m1 by x square is equal to gm2 by d minus x whole square. If you have taken from m2 means gm1 by d minus x whole square is equal to gm2 by x square. So here the formula is this one only, but here m1 by m2, m2 by m1 will be varies. So that not the point. So here m1 into d1 minus x, but here m2 into d minus x will come, root m2 into d minus x. That is only the formula. Therefore here by m2 will come. So this is null point distance. There will be no negative mass. That's why m1, m2 are positive only always. But m1 can be less or m1 can be greater. That means one is less, one is more. In that case, so one example, m1 is less than m2. So now m1 less than m2 means 1 is less than m2 by m1. That means m2 by m1 is greater than, means m2 by m1. 1 is less means m2 by m1 is more than 1. So this value, the root of m2 by m1 also become more than 1. Okay. So now x value will become d by 1 plus greater than 1. That means can be 1.5, 1.7, 1.6 or 2, 3 like that. So then the x value will be less than d by 2. X value less than d by 2. So here I have taken x is from m1. Therefore, less than d by 2 means it is come nearer to the m1. So I hope you understand this. Whereas coming into electric field variation. So electric field source is charge Q1, Q2. Initially I will take both are positive charges. So there is a in the x distance from Q1 charge. In the x distance from the Q1 charge. X distance from Q1 charge. There's a null point is here. So null point is here. Then the field on this unit charge, here some consider a unit charge. The unit test charge is always positive in electric field, I explained. You have to take positive test charge. Then it is a repulsive. The E1 is in this direction, E2 is in repulsive direction, positive, repulsive direction. So then these two are equal in magnitude and those two are positive. Therefore, kq1 by x square is equal to kq2 by d minus x square. So then this is answer. Finally, we will get answer like this. So now, similarly, if q1 less than q2, suppose q1 is less than q2, 1 is less than q2 by q2 by q1, that means q2 by q1 greater than 1. This value, x value will become positive. That means where I have taken, that is correct. Direction of the x I have taken, that is correct. Positive direction. And if we are q1 equal to q2, it will lies charges are q1 and q2, positive charges, similar nature, similar charges, identical charges, and similar nature, positive charge. Then it will be lies between, in between the charges. Equal to means d by 2 at the center compulsory. Here also mass are equal means at center. Between them null point is lies. So whereas 1 is negative, so consider here 1 is negative, 1 is positive. So there is a test charge present here in between this point and outside the q2, right side of the q2, left side of the negative q, that means q1. So consider like that. So if you take directions on this test charge for these three different positions, so there is a possibility to become 0 at this point, see, at this point and at this point. So here only the chances are there to become 0. In between, see here, if you take here at this point, so two fields are in the same direction, so it is not be 0. So there is a possibility to get the 0 outside. And any one side if you consider, so their field should be equal and opposite direction. Field should be equal and opposite direction. Then x is equal to, finally the x is equal to, you will get d by root over q2 by q1 minus 1. It is very important. So this side also same will get, means at any point either right side or left side, formula is same. X is equal to d into d by root over q2 minus q2 by q1 minus 1 or q1 by q2 minus 1. That is already as discussed in gravity, q2 by q1 or q1 by q2. q2 by q1 denominator means I have taken from q1. X is from q1. q2 by q1 by q2 I have taken means that is from q2. Right? Denominator is q2 means that is from q2 side. Denominator q1 means that is from q1 side. So now here see, same concept we apply. For example, here q1 equal to q2 and negative charges. Any one is negative. q2 is negative or q1 is negative. q2 or q1 is negative. So in this case, null point, see here q1 and q2 are both are equal. And q1 by q2 is equal to 1. 1 minus 1, 0. Therefore, x will be infinity. So there is no null point. Null point is at infinity. It is not lies between or any other near point of either q1 side or q2 side. So here also electric field lies near the smaller magnitude of charge. The electric field lies nearer to the smaller magnitude. For example, if q is equal to, if negative charge is smaller in magnitude, this is equal to minus 2 coulombs, it is equal to 3 coulombs, then it will be minus 2 side only. Okay. if it is minus q is equal to 5 coulombs, minus 5 coulombs, and plus q is equal to, plus charge is equal to plus 2 coulombs, then it will be lies near the 2 coulombs only, plus 2 coulombs only, this side. So only magnitude of charge which is small, not negative and positive. Charges are negative and positive. In that case, it is outside the charges, either right side or left side. So how we defined means the magnitude of the charge, which charge is less. Positive charge less means positive side. Negative charge less means negative side of the charge. Negative side means that side of the charge. Okay. So this is clearly, you can, while you are solving the problems, you can understand it. Next, coming into magnetic field. In case of magnetic field, here you need to understand first of all earth magnetism. So for small concept, I tried to explain here. So these north, south, east, west directions are geometrical directions. These are geometrical directions. But if earth is a magnet, then the south of the earth is this side. Geometrical north and south pole, magnetic pole of the earth. South pole of the earth is towards the north, and north pole of the earth magnet is towards the geometrical south. This is the point you have to remember. Why this I'm giving means to understand the magnetic field lines outside the earth. Outside the earth magnetic field lines. Outside the earth magnetic field lines. So they are from south to north. Here like this. Geographical south to geographical north. So these are the directions of means space. But earth poles, these are the magnetic poles. These are the directions of geometrical north, geometrical south, and east west. I hope you understand geometrical north, south, and south to north poles of the earth. I tried, I think so. Right, next to get the clarity. Now these are the earth magnetic fields, and this is a bar magnet. This is bar magnet consider. So the bar magnet north pole is toward the geometrical north. The geometrical north and north of the bar magnet are in the same direction. Okay, both axes of bar magnet and geometrical north and south axis are both are same. The axis of bar magnet lies on the geometrical north and south. So like this. So now if you see field lines by this bar magnet and the field lines of earth magnet, at these points they are opposite direction. That means field will be weak. Opposite direction means subtracted field. Those two, field is a vector. So one is a field by magnet, bar magnet what I have taken, and this is a field already there by the earth. Means this is the experiment doing on the surface of earth magnetic field. So therefore bar magnet and direction of earth magnetic fields are opposite here. So only one line I have taken and explaining. These two are opposite means subtracted. So field will be here weak. Here it will be strong. On the axial line, field will be strong. On equatorial line of the bar magnet is 0. Field is 0. Means weak or both are equal fields means at that point null points will come here. Where the field due to magnet is equal to the field of earth. So in place to place magnetic field will be vary on the earth surface. So in AP I know that is 0.693 Teslas. So that will be Henry by meter square Tesla. So like that. So here on north pole means equatorial line, when the magnet is placed, bar magnet placed such that north pole of the bar magnet in the direction of geometrical north. So this is called tan B position, means perpendicular to the equatorial line. So now here similarly the south pole of the magnet, opposite direction, south pole of the magnet is aligned in the geographical north pole. So this is geographical north pole and south, east, west, right? So south pole of the magnet toward the north pole of geographical north. Then field lines are as shown in the figure. So if we see field lines, so as we discussed, depends on the field lines of magnet. We can say south pole is act like a negative charge, north pole act like a positive charge, because the field lines from the positive charge, the moving away, they are away outwards field lines. Similarly, in the magnet north pole also, so they are moving away north pole. The field lines from the north pole of the magnet, they are moving away. So positive charge and north pole both are similar. Similar we can take. This is opposite negative. So that concept based on the field lines. So now here on this equatorial line, the field is strong on the axis, along the axis of the bar magnet. Field line is means field will be 0. Therefore, field lies on axial line. Null points are lies on axial line. So this is tan A position. Tan A position on axial line. So here that this one is tan B position. We can check the magnetometer, tan A position and tan B position. So here there is a magnetometer will be there. So two arms are this. Here there is a compass needle will place. Magnetic substance. Compass needle means tiny magnetic substance. So for example, here I am placing magnet parallel. So no deflections means here null points, right? So for example, on the arm perpendicularly I am placing here. So no deflections on this means it is the magnetic substance on equatorial line. Therefore, this is tan B position. This is tan A position. So on the arm parallel to the arm, so magnetic substance needle cannot be deflected any direction. So then it is tan A position. Here tan B position. No deflections in the magnetic field observed by placing this magnet perpendicular means field null points on equatorial line, because this will come on equatorial line. So it will be tan B position, tan A position. So I hope you understand this. Thank you.